So here we have an example of proving a trig identity. So the directions being we want to prove this identity. And we want to take a clue here from our target expression here. Notice that our right side we have one term, 2 times cosecant squared of x. And on the left side we have 2 terms. So we need to get rid of these 2 terms, and we'll do that in this case by combining these fractions. To do that we need a common denominator first. So we're going to take our first fraction, 1 minus cosine of x, and we need to decide first of all what is our common denominator. And in this case we're simply going to have a product of these two. So we're going to multiply top and bottom by the other denominator. So in this case, let's undo that. In this case, we're going to have 1 plus cosine x all over 1 plus cosine x. Got to remember that these need to be grouped. And we'll take the second fraction, 1 over 1 plus cosine x, and we will multiply that by our other denominator from over here. And so we get 1 minus cosine x. I'll put those in some parentheses. Okay. So this left-hand side equals this. We're just manipulating the left-hand side of the original equation. And so when we multiply here we have 1 minus cosine x, 1 plus cosine x, and back when we were working with some algebra, you might remember that we have this identity, a plus b times a minus b equals a squared minus b squared. Minus. Okay, if you multiply these two binomials, their middle terms will cancel, leaving you with a squared minus b squared. Well, that's going to help us down here, because you can write this all out, but really we just have an a minus b and an a plus a b. And so let's multiply that out. On top we just have 1 plus cosine x. And on bottom we're going to have our 1 squared, which is 1, minus cosine of x squared. Okay. And over here we're going to have 1 minus cosine of x all over 1 minus cosine squared. And so we have our common denominator. So the top expression equals that, equals this. We have 1 plus, we'll write it out, plus 1 minus cosine x. And in the denominator, we have 1 minus cosine squared of x. Keeping in mind here when we're proving an identity, we want to take reasonably simple steps. Not that we're not able to do a couple steps in our head, but the idea of a proof is we want to prove that this must be true. So, to wrap this up here, we're almost there. We notice on top we have 1 plus 1, that's going to be 2. Cosine of x positive and negative cosine of x, that's going to make 0. And then we have this expression down here, 1 minus cosine of x, and we remember from our Pythagorean identity. Pythagorean identity says sine squared of x plus cosine squared of x equals 1. So if we subtract cosine of x from both sides, we end up with sine squared of x equals 1 minus cosine squared of x. And so we can take this expression and substitute it there. Okay? And so, let's get this out of here. So let's go ahead and do that. Continuing on. We have, on top, as we said, we'll have 2, and the bottom just becomes sine squared of x. Okay. So if we pull this out, we have 2, and we have 1 over sine squared of x, and 1 over sine squared of x is just going to be cosecant of x. We can make that jump. And there we have it. And so we've taken the first expression from the left-hand side, manipulated that expression, and we ended up with the right-hand side. And so we have proven the identity and shown it to be true.
Made with Doodlecast Pro.